Hi, in this question 4 here, it's a probability question. To be honest, I think most, if not all of this could be done as easily, if not more easily, on your scientific calculator than it can be in your GDC, but I thought I'll just have a quick brief look at the whole question so you can get a sense of it. So at a school, 70% of the students play a sport, 20% are involved in theatre, 18% do neither, and a student is selected at random. We have to find the probability that the student plays a sport and is involved in theatre. So really quickly, how I use my calculator to help me solve this is initially I will be looking at this as a Venn diagram problem because I've got two sets of data, one which represents sport, one which represents theatre, and you can see I've got that in the universal set with 0.18 being the students who are involved in neither, like so. You can see that although this is all in percentages, and you could work this with 70, 20, and 18, I think it's better to work in decimals. So hopefully you can do that kind of conversion in your head. 70% is 0.7, 20% is 0.2, and 0.18 is 18%. So in order to, what I'd be doing ultimately is I'd be filling in all of these parts of the circle here so that I can then solve any problems that come my way. So for example, I know that this whole circle needs to represent 0.7. This whole circle here needs to represent 0.2, and I need to work out the intersection here, which is intersect T. So it's S and T here. So I'm going to use the formula, the probability of S or T, which is this whole thing here, is equal to the probability of S plus the probability of T minus the probability of S intersect T. If I use that formula and solve for S intersect T, I'll get this, and therefore I can work out these two things here. So what is the probability of S union T, S or T? Well, if 0.18 of the student population do neither, then the opposite of that must do one or the other or both. So that would be 1 minus 0.18, which gives us 0.82. So that's what we're working with. These circles here have to add up to 0.82. Okay, so because of the formula, I'm going to take the 0.82 and I'm going to subtract the 0.7, which is the people who play sport, and I'm going to subtract the 0.2, which are the students involved in the theatre, and I get negative 0.08. So negative 0.08 would be what negative the probability of A intersect B is, or S intersect T, and so therefore the probability of S intersect T is 0.08. So in here, now I'm just using my mouse here, so it's going to be really dodgy. I'm going to have here, I'm going to have 0.0, look at that, isn't that awful? 8. And because of, now that I've got that, oh man, this is going to be so struggly. Okay, because I've got that, I can now work out this bit of this moon bit, and this moon bit here, I suppose. So we're going to have 0.7 minus 0.08, which is 0.62. So this bit in here is 0.62. So bad. And then this bit in here is going to be 0.2 minus 0.08, which I can probably figure out in my head, but can't be bothered. So I'm left with, 0.2 minus 0.08, and I'm left with 0.12. So 0.12. Oh man, that's awful, isn't it? But I can't bother fixing it because it's not important. So there's that one there. So part A, find the probability that the student plays a sport and is involved in theatre. My Venn diagram supports everything else that I'm doing here. So I can just go to 0.08, and you can see in the mark scheme, clearly labelled Venn diagram for a method mark, and then you've got the probability of S intersect T is 0.08, or accept 8% for another mark here. Part B was find the probability that the student is involved in theatre but does not play a sport. Great. I can go straight to this part of it, can't I? Does not play a sport involved in theatre. So that's 0.12. So because I've done my Venn diagram to start with, clearly labelled Venn diagram, mark 1, then 0.12, 2 marks. So even though it's a bit of work to put the Venn diagram together, you can do the rest of it fairly easily. At school, 48% of the student are girls and 25% are involved in theatre, and so on. I'm not going to do any more. If you want a full solution to question 4, do let me know. But effectively, you continue to use your calculator to solve for decimal answers effectively, like so. And that's the only reason why you're using your graphics display calculator. There is no need at all to use it in any more involved way. Okay, I'll leave that here, and we'll get on to the next video.